Hello everyone. I want to welcome you to Introduction to C++. My name is Shivani Sharma and I will be your guide for this course. I have completed my education from IIT Kanpur and have specialization in C++. This course has been prepared to help you understand the basic to advanced concepts related to C++. I hope you have an enriching learning experience and achieve the best out of this course. In this course, we will use an IDE built to meet the most demanding needs of its users and also is easy to use and understandable. Hence, code blocks will be used as an IDE for this module. Let us now see how to install code blocks in the system. Search for code blocks. Click on the first search result. Come to Downloads. Click on Binaries. Click on the option which reads code blocks 17.12 mingw.setup.exe. Here it's the fourth result. Come to Download from section and click on sourceforge.net. And your download will start in few seconds. C++ is an extension to C language and was developed by Bajani Stroustrup at Bell Labs. It is a middle-level programming language as it comprises of both high-level and low-level language features. Now let's start with the basic concepts of C++. Alright, let's start with our first topic, C++ character set. Character set is a set of valid characters that a language can recognize. A character represents any letter, digit, or any other sign. These are few C++ character set: letters, digits, special symbols, white space, and other characters. Our next topic is tokens. Individual words and punctuation marks are called tokens or lexical units or lexical elements. In other words, the smallest individual unit in a program is known as a token. C++ has 5 tokens. Let's take a look at each of them. The first one is keywords. Keywords are the words that convey a special meaning to the language compiler. These are reserved for special purpose and must not be used as normal identifier names. Some of the examples are shown. Next is identifiers. Identifiers are fundamental building blocks of a program and are used as the general terminology for the names given to different parts of the program, which are variables, objects, classes, functions, arrays, etc. An identifier is an arbitrarily long sequence of letters and digits. The first character must be a letter. The underscore is also counted as a letter. A very important point to be noted is C++ is case sensitive as it treats upper and lower case characters differently. Here are some examples. Literals. Literals are data items that never change their value during a program run. C++ allows four kinds of literals. They are integer constant, character constant, floating constant, and string literal. Integer constants. Integer constants are whole numbers without any fractional part. An integer constant must have at least one digit and must not contain any decimal point. It may contain either plus or negative sign. A number with no sign is assumed to be positive. Commas cannot appear in an integer constant. Character constant. A character constant is one character enclosed in single quotes. A point to be noted is a character constant in C++ must only contain one character and must be enclosed in single quotation mark. Floating constants. Floating constants are also called real constants. Real constants are numbers having fractional parts. They may be written in fractional form or the exponent form. The last one is string literal. Multiple character constants are treated as string literals. A string literal is a sequence of characters surrounded by double quotes, as shown in the example. Punctuators. Punctuators in C++ are known as separators. Few of the punctuators are brackets, parenthesis, braces, comma, semicolon, colon, asterisk, etc. The last one is operators. An operator is a symbol which performs specific mathematical or logical manipulations. There are two types of operators: unary operator and binary operator. Unary operator is that which requires one operand to operate upon, and binary operator is that which requires two operands to operate upon. In the example shown, ampersand, asterisk, increment operator and decrement operator are some of the unary operators, and addition, subtraction, less than, greater than sign, etc. are binary operators.
In any language, there are some fundamentals you need to know before you can write even the most elementary programs. Two such fundamental concepts of C++ will be discussed here. First is data types and second is variables.
Data types. Data types are means to identify the type of data and associated operations of handling it. Data types are of two types: fundamental type and derived type. Fundamental data type. Fundamental data types are those that are not composed of other data types. There are 5 fundamental data types. First, int. They have no fractional parts. An identifier declared as int cannot have fractional part. An integer data type occupies 2 bytes of memory space. Second is char. Character can store any member of the C++ implementation's basic character set. If a character from this set is stored in a character variable, its value is equivalent to the integer code of that character. An identifier declared as char becomes a character variable. Char type is often said to be an integer type. It is said so because letters, symbols, etc. are represented in memory by associated number codes. Char data type occupies 1 byte of memory space. Next is float. A number having fractional part is a floating point number. Floating point numbers have two advantages over integers. First, they can represent values between the integers. And second, they can represent a much greater range of values. But floating point numbers suffer from one disadvantage also. Floating point operations are usually slower than integer operations. Floating data type occupies 4 bytes of memory space. Next is double data type. The data type double is also used for handling floating point numbers, but it is treated as a distinct data type because it occupies twice as much memory as type float and stores floating point numbers with much larger range and precision. Double data occupies 8 bytes of memory space. Last one is void. The void type specifies an empty set of values. It is used as the return type for functions that do not return a value. There are 4 types of data type modifiers: long, short, signed, and unsigned. Long and short modify the maximum and minimum values that a data type will hold. A plain int must have a minimum size of short. Here we can see the size hierarchy for int, that is integer, which says short int is the smallest, then comes int, and highest is the long int. And then for the size hierarchy for float data type, float is the smallest, then comes double, and long double is the highest. Signed types includes both positive and negative numbers and is the default type, whereas unsigned numbers are always without any sign, which means that they are always positive. Derived data types. Derived data types are object types which are aggregates of one or more types of basic data types. These are of 4 types: array, functions, pointers, and constants. Array. An array is a collection of the same basic types of data that is contiguous in memory. Array can be one-dimensional, two-dimensional, or multidimensional. Functions. A function is a named part of a program that can be invoked from other parts of the program as often needed. Functions are used to provide modularity to a program. Also, make a note that a function name always ends with the parenthesis as shown in the example. Pointers. A pointer is a variable that holds a memory address. This address is usually the location of another variable in memory. If one variable contains the address of another variable, the first variable is said to point to the second. Constant. The keyword const can be added to the declaration of an object to make that object a constant rather than a variable. Thus, the value of the named constant cannot be altered during the program run. As in the example shown, const is the keyword that must be used for declaring a constant. There are some derived data types that are defined by the users. These are known as user-defined derived data type. They are of four types: classes, structures, union, and enumeration. Class. A class is a collection of variables and functions. The keyword is class. Second is structure. A structure is a collection of variables referenced under one name, providing a convenient means of keeping related informations together. A structure is different from a class in the sense that a class can represent data elements as well as their associated functions, whereas a structure can represent only data elements, not their associated functions. The keyword is struct. Next is union. A union is a memory location that is shared by two or more different variables, generally of different types at different times. The keyword is union. The last one is enumeration. An alternative method for naming integer constants is often more convenient than const. This can be achieved by creating enumeration using the keyword enum. Now we come to our last topic of this module, that is variables. So what are variables? Variables represent named storage locations whose values can be manipulated during program run. The variables are called symbolic variables because these are named locations. Now let's have a look at how a variable is declared and initialized. The basic syntax to declare a variable is type name, where type is any C++ data type and name is the name of the variable. A variable name is an identifier. Initialization of variables. When we declare a variable, that variable is uninitialized and the variable's value is set to be undefined. However, a first value may be specified in the definition of a variable as shown in the example. Dynamic initialization. C++ permits initialization of the variables at runtime. This is referred to as dynamic initialization. In the example shown, it will initialize average using the information available at runtime, that is, using the values of sum and count known at runtime. Now, an important note on variables. Variables that are not initialized are not empty. If you do not initialize your variables, they will contain junk or garbage values left over from the program that last used the memory they occupy now, until the program places a value at that memory location.